All right,
Oh,
so
yeah, that one.
let's talk about one, 2, and 3 from chemical equations. One was multiple choice, but 2 was not. Some of you submitted a multiple choice answer on number 2. I didn't give you credit for that if you did it, because it's not what it tells you to do. So number 1 was pretty easy. What's the correct answer? C, right? B and D can't be balanced equations because they're not even equations, right? There's no arrow in it. It's like having no equal sign in math, all right? So the real choice here is between A and C. Number 2, you're supposed to balance these equations. And all you really had to say on A is that it's already balanced, right? If you count, I just always start on the left-hand side with the first element. There's 1K, and then there's 1K on the right side. There's 1O, 1O on the right side. There's 2 H's, 2 H's on the right side. 1 Cl, 1 Cl on the right side. That's the easiest way to do it. For letter B, it's a little bit more complicated. You've got 1 Na, and you've got 2 Nas over here. Remember, you can't add subscripts. You can only add coefficients. So to make them even, we just put a coefficient of 2 in front of this whole thing. That means we've got 2 of all of these. So now we have 2 Nas, 2 Nas. We've got 2 H's, 2 H's, 2 C's, 1, 2 C's, 6 O's, 1, 2, 3, 4, 5, 6 O's. So that's all you had to do to balance that. Okay? And then letter C is the most complicated. We said what's in parentheses here. The 2 on the outside means there's 2 times this quantity. So there's 2 N's and there's 6 O's. So the first one, PB, we've got 1 and 1, so that's fine. Then the N's, we've got 2 N's, but we only have 1 N over here. So we're going to have to put a coefficient of 2 in front of that whole thing. Now let's count the O's. We've got 6 O's. We've got 2 times 3, 6 O's. We've got 1K, we've got 2 K's. So we need to put a 2 in front of this Ki. So the K's are balanced. Now we have 2 I's and we have 2 I's. So that balances that one. On number 3, it says explain why balancing an equation requires changing the coefficients in front of the chemical formulas rather than the subscripts within the chemical formulas. So here's what we're going to say. Changing, and my pen's running out here. Changing subscripts, comma, changes the substance. So if we change H2O to H2O2, it's no longer water, right? That's why you can't change the subscripts. But you can add a 2 in front of it and say we have 2 waters, is all that we're saying, by adding coefficients. So let's let's talk about the worksheet now. Any questions on the section 1 review side? Kale, question on that side? Number 2, I guess I'm just going to talk about all of it. All right. So number 1, what are 3 clues that tell you a chemical reaction is happening? Gas produced, solid produced, energy released. You might have just said light energy, sound energy. I just said energy. Predict, well, it says caramel forms when table sugar reacts with oxygen. What elements make up caramel? So C, H, no. They have to, right? Because that's what we start with. Number 3, identify whether or not each of the following is a chemical reaction. Explain your answers. So melting ice, no, because it's still water, right? So we haven't changed anything. Burning a candle, yes. Resting iron, yes. Let me move it up so we can see 4 and 5. Number 4, what's the role of energy in forming bonds? Energy is needed to form bonds and released when bonds are broken. Energy is needed to form bonds and released when bonds are broken. And then number 5 is a firecracker exploding, an example of an endothermic or an exothermic reaction. That's pretty simple. That's exo. And it says explain. Energy is released when a firecracker explodes. All right? So let me erase that. Let's flip it over to the back. And I'll just go through all this real quick too. What are the reactants in this chemical reaction right here? That's just Zn and S. What's the product? It's ZnS. What's the state? It's Cr, which is a crystalline solid, or if you just put solid, that's fine too. According to the law of conservation of mass, the total mass of the product in this chemical reaction is 14 grams. What's the combined mass of the reactants? That's 14 grams. Number 5, what's the product in this reaction? It's H2O. Let me get the other pen. What are the reactants? H2 and O2. What are the states of the reactants? They're gases. What's the state of the product? It's a liquid. What are the coefficients tell you about the ratio of the reactants? We've got 2 H's to 1 O. So 2 to 1. And then how many units of the product are produced? It says 2 H2O, so 2. So let's move it up so we can see 11, 12, and 13. Number 11, 2 units of sodium, so 2 Na plus 1 unit of chlorine. Chlorine we said is Cl2. It's a diatomic molecule is what we call it. Produce 2 units of sodium chloride, so 2 NaCl. Number 12, 1 unit of methane gas, CH4, plus 2 units of oxygen, so 2O2, yields 1 unit of carbon dioxide, CO2, pens again, plus 2 units of liquid water, 2 H2O. Number 13, 1 unit of aqueous, that just means dissolved in water, aluminum sulfate, which I think I said it was Al2SO4 in parentheses 3, plus 3 units of barium chloride, 3 BaCl, is it 2? Yeah, BaCl2. Yields 2 units of aluminum chloride, so 2 AlCl3, plus 3 units of barium sulfate, so 3 Ba, I think it's no, it's just BaSO4. Which, if you didn't get that one, I think we scratched that one out anyways. Okay? But that's what the correct answer would be. Okay. So, this is what I had up when you came in. This is what we're going to do at the end of the hour. All right? So, you're going to read the section over Law of Constant Proportions, which is attached on Canvas. There's just 2 pages, 119 and 120. There's no questions. But you're going to take notes over it and submit the notes to me for 5 points. All right? Shouldn't take you very long. I'm not saying there's going to be a whole page of notes. Maybe a quarter of a page of notes would be it. All right? That's what I'm looking for. So write that in, and then I'll show you the lab that we're going to do here in just a second.